Here you see that given problem is y is equal to 16 minus px minus x square is equal to 25 minus q plus x whole square. For all real values of x, p, q are both positive. These are given. And we have to calculate p and q. From here p and q we have to find out it, and we have to state the maximum value of y. What's the maximum value of y, and at which value of x the maximum of y occur. Okay, we have to find out that value of x, for that value y is maximum. Okay, and find out the range of the values of x for which y is positive, and where y is positive we have to find out for those values, those range of x. Okay, to find the value of p and q we have to manipulate this equation. Okay, so what is given here? Given here 16 minus px minus x square is equal to 25 minus q plus x whole square. So just manipulate it. 16 minus px minus x square, that is 25 minus q square minus 2qx minus x square. Okay, now we take all the numbers, all the p and q on one side and other in another side. Okay, so here you see minus px, from that side it's coming here plus 2qx, from that side plus q square, and here we can get x square minus x square and minus x square, both sides we can cancel this. Okay, so we are left here 25, from that side is going minus 16. So here we get, if we take x outside, it becomes 2q minus p plus q square, and here we get 9. Now we compare both sides. Here there is no term with x, so that we can consider the term with x is 0. Coefficient of x is 0. So we get, comparing both sides, we get here 2q minus p is 0 and q square is 9. How could we get it? Because there is no term of x, so we can say that coefficient of x here, as there is no x, so this is 0, and the constant term here is q square, here is 9, so q square is equal to 9. Okay, so from there we can say q square is equal to 9. This gives us q is equal to maybe plus minus 3. If we take the root on both sides, so we can get q is equal to plus minus 3. But here it is given that p, q both are positive, so we will consider only the positive value. So q is 3. Okay, as q is 3, so from 2q minus p is equal to 0, we are putting the value of q here. So 2 into 3 minus p is equal to 0. So we can get 6 minus p is equal to 0. From here p is equal to 6. So we got p is equal to 6, q is equal to 3. So first problem is solved. Find the value of p and q. We have got it. Now we are coming to the next problem. State the maximum value of y. Okay, y have two expressions. Okay, but to find the maximum value, we will take the second expression, 25 minus q plus x whole square. So you can see here 25 minus 3 plus x whole square. So if we take this portion 0, our value of y become maximum, because this portion is always positive and it is a square. It never be negative. So as it is subtracted from here, so if it is 0, the value of y will be maximum. So the maximum value of y is 25. Okay, and when it is possible, when 3 plus x is 0. That means, so x is minus 3. So maximum value of y is 25 and it will occur when x equal to minus 3. Okay, so the second problem, maximum value of y and when it occur, is solved now. Okay, now we have to find out the range of values of x for which y is positive. But y is equal to, we can take any of these two expressions. So y is equal to 16 minus px minus x square, and we got 16 minus, we got the value of p is 6, 6x minus x square. Now we will factorize this. Okay, 16 and x square. So 8 into 2 x. So if we take this become minus 8x, this become 2x, this gives minus 6x. Okay, so we have got, here is 8 plus x into 2 minus x. Okay, now this is given here that value of y is positive, so it is positive. Okay, so here also we can see that we have to find out the range where y become positive. So here we can get a terminal point is x equal to 2 and x equal to minus 8. So three cases may arise. One is x is less than minus 8. One is x is greater than 2. And in the middle there is x is greater than minus 8 and less than 2. Okay, three cases may arise. Now we consider each of these. If we take x is greater than 2. If x is greater than 2, it is positive. If x is greater than 2, it is negative. If x is greater than 2, it is negative. And multiplication of positive and negative gives us negative. But given that the value of y is positive, so we would not consider this case. X is greater than 2 will not be included in this range. Okay. Now we consider if x is less than minus 8. If x is less than minus 8, that means x may be minus 9, minus 10 or maybe any real number. This part will become negative. Okay, and if x is less than minus 8, this part become again positive. Minus 9, minus 8, whatever you take the value of x negative, it become positive and this gives us positive value, and the multiplication gives us negative. So this case also would not be considered. Okay, but if we consider this case, x is greater than minus 8, less than 2. If x is less than 2, this become positive. If x is greater than minus 8, this become positive, and multiplication of this come positive. If you can take any value like 0, if you take 0, 0 is belongs to in this interval. If you put here 0, this is 2. If you put here 0, this is 8. So both are positive, and the multiplication gives us the positive value which included in our given range. So range here, range of x is greater than -8, less than 2, when y is positive. Okay. Look at our next problem is calculate the value of k for which the line y is equal to 2x minus 2k is a tangent to the curve y is equal to 2x square minus 6x plus 5. Okay. First of all, tangent, it touches the curve. So there must be a point of intersection of this line to that curve. So to find this, we have to solve this simultaneous equation. Okay. So here y is equal to 2x square minus 6x plus 5, and here it is given y is equal to 2x minus 2k. So what we substitute the value of y in this equation. Okay. Substitute this value in this equation. So we get 2x minus 2k is equal to 2x square minus 6x plus 5. Okay. Now this become 2x square minus 6x. We are taking the value on that side, that is minus 2x. This is 5 plus 2k is equal to 0. We are taking all these value to that side. So 2x square minus 6 was before. From here it is going to that side, so become minus 2x. 5 is there, and from that side is going to k. Okay. So this is 2x square minus 8x plus 5 plus 2k is equal to 0. Okay. Now it is given that this is the tangent to the curve. What does it mean? Tangent means it touches the curve only at one point. Okay. So the discriminant of this equation will be equal to 0. If it is 0, we can get only one point. Okay. Only one point where the line touches the curve. So we have to find out the discriminant of this quadratic equation. So here it is ax square plus bx plus c is equal to 0. So comparing this with the given equation, we get b square minus 4ac. So from here we get minus 8b square minus 8 whole square minus 4 into a means 2 into c means 5 plus 2k is equal to 0. So b square minus 4ac is equal to 0. For that, we can get only one value of x for which the line touches the curve. Okay. So from here we get 64 minus 8 into 5 plus 2k is equal to 0. So here 64 minus 40 minus 16k is equal to 0. So here from 4 to 16k. So k is 24 by 60. That means 3 by 2. So k is 3 by 2. So we have to find out the value of k That is already we have find, that is k is equal to 3 by 2.